David, are we going to go back deep into the contractor reports that you wrote for NASA, which you introduced us to in our last video?
Yes, we are. In fact, based upon information from Chapter 3 of Volume 2 of those reports, we call this video The Hidden Side of Electricity. It's all around us, but little known and seldom taught. You may have never heard about it, so keep watching. You don't want to miss this one.
Drank my wine, me and my magic man kind of feeling fine. He had a cloak of gold and eyes of fire, and when he spoke I felt this deep desire. From its fear and pain, and help the people to feel free again. Why don't we listen to the voices in our heart? 'Cause then I know we'll find we're not that far apart. Everybody's got to be happy, everyone should sing. 'Cause we know the joy of life, the peace that love can bring. Thus spoke the wizard in his mountain home. The vision of his wisdom means we'll never be alone. And I will dream on my magic night, and the million silver stars that guide me with their light.
So David, here we are now back with video 23, and you said the hidden side of electricity. What is that? What are we actually going to cover today?
Bjorn, this video, as I mentioned, is derived from Chapter 3 of Volume 2 of the two contractor reports I wrote for NASA. And we provide links below if you want to obtain your free copies of these reports if you want to go deeper. However, as our intent is to present the story behind the science of the hidden side of electricity, we present two videos produced in 1988 by three experimenters in Southern California who called themselves the Borderlands Science Research Foundation, or BSRF for short. These gentlemen are Peter Lindemann, there he is again, Eric Dollard, and Tom Brown. Their two videos are available to watch in their entirety for free on Eric Dollard's website. We provide the links below. I used information from these videos when I wrote Chapter 3 of Volume 2 about 20 years ago. The title of the first video is Transverse and Longitudinal Electric Waves. And the second video is Tesla's Longitudinal Electricity.
Okay, David, wait. So transverse and longitudinal electric waves. So before I get too disoriented, could you help me clarify those concepts a little bit?
I say let's watch this short excerpt from that first video, Transverse and Longitudinal Electric Waves, and see what we see.
Okay.
We have water, and everybody understands the waves in water, which we can call a transverse waveform, standard waveform. And we know standard waves as they go along in the water. And the movement of the water is up and down, just like we know a boat on the water will go up and down. And the energy flow goes in this direction. So a transverse wave, we have a phase quadrature between the movement and the energy flow. And here we have longitudinal waves. And a longitudinal wave could be like a tidal wave or a tsunami, which we know is undetectable till it hits the shore. So as it goes through the water, the movement of the water is linear and the energy flow is linear, so we see it's in phase conjunction. In the direction it goes in, the boat on the top will receive no up and down motion from that wave. And to get a more practical demonstration here, Eric Dollard will demonstrate. We have here a piece of BX cable, and I'll just act as the ground on this.
Okay, to start with, our transverse wave, which will be our quadrature motion, be represented by this form. We can see, have an exact analogy to what's drawn on the board. If I transmit just one pulse, you can kind of see it takes a long time to get to the other end. But the longitudinal wave, of course, is over there almost immediately, and other than, the slippage at the other end, it's almost undetectable that this wave even exists, other than that little shaking around. But it's slower. There we go. See, there's really not much motion up and down or around, but it's there right away. As soon as I move my hand, the other end responds, where in this case it takes a very long time to get there. So this serves as a very practical analogy of these two types of waves.
All right, that makes it a lot clearer, David. Thank you. It's quite a memorable demonstration they do there.
It really is. Tesla showed that his Tesla coils produced a combination of transverse and longitudinal electric waves which spiraled from the ends of the coils. Yet, college students today are taught that longitudinal electric waves do not exist.
Do not exist, huh? So if they do exist, has anyone then ventured to try to compare the two, side by side, transverse electric waves and longitudinal electric waves, and see how they make it? I would imagine that since you're presenting these videos to us today, that these BSRF researchers might have ventured to do just that.
Bjarne, you are right. And they succeeded. To measure the velocity of transverse electric waves, the BSRF researchers connected a low-power radio signal to the input end of a conductor of known length. The resonant frequency for that conductor, where the signal at the output end is maximum, was measured. Then, the transverse electric wave speed, or velocity, was equal to resonant frequency times conductor length times 4. The constant 4 is used because the maximum signal throughput is when the conductor is 1/4 of the wavelength. A similar procedure was used to determine the velocity of longitudinal electric waves, except that the input signal was capacitively coupled to the conductor. A different resonant frequency was measured for this arrangement, and then with the same equation used for transverse electric waves, the speed of longitudinal electric waves was determined. The results were the measured transverse wave speed was 2.44 times 10 to the 8 power meters per second, which equals 0.81 times c, where c is the commonly understood speed of light. And the measured longitudinal wave speed was 3.74 times 10 to the 8 meter per second, which equals 1.25 times c.
What? 1.25 times c? David, that's faster than the speed of light.
Calm down. Remember, we are presenting things that have been hidden. 1.25 times c might seem impossible due to Dr. Albert Einstein using the value of c, which is 3.00 times 10 to the 8 meter per second, to be an upper speed limit for matter or energy. C is the speed of transverse electric waves in free space. When the speed of longitudinal electric waves is measured, this value can be many times the speed of light. And in fact, Tesla claimed that longitudinal electric waves with speed many times the speed of light were produced by his Tesla coils.
Many times the speed of light even? Well, I'm kind of glad if the speed of light is not the upper speed limit, because otherwise it would have taken the Enterprise many, many years just to come to a few nearby stars, and Star Trek would have had to be over many, many episodes ago.
Absolutely. I used to love that original Star Trek show. And yes, it makes you wonder, is there perhaps more science in the science fiction than we used to believe? In any case, transverse electric waves and longitudinal electric waves are both forms of electricity, but are very different from each other.
Okay, so if these BSRF researchers in their first video venture out to break the so-called cosmic speed limit, what do you see as the highlights of their second video, the one called Tesla's Longitudinal Electricity?
Well, referring to page 50 of volume 2, the BSRF researchers used a modified Tesla coil to conduct longitudinal electric waves into a filament type light bulb using one wire. It lit up, and they said the light was more bluish than a normally wired bulb. Then they said that a person's finger could feel a force pushing out from the bulb, but surprisingly a piece of copper foil was pulled in towards the bulb. And in my opinion, most importantly, they showed that that bulb, when fed with longitudinal electric waves, was able to charge a capacitor at a distance with no wires. That was energy being transported into the capacitor with no wires. I still think that is amazing.
Wow, a bulb charging a capacitor wirelessly at a distance. That is amazing. Okay, that's a good one. Anything else from this video that jumped out at you?
I was impressed with Peter Lindemann's detailed description showing how they constructed their two Tesla pancake coils. That's the name given to flat coils like are demonstrated. The original plans were from Tesla's patents, but scaled down in size. These researchers were saying that even though these coils were very different compared to the present understanding of how coils and other electrical components function, they worked. Finally, I was impressed to see how the two coils, transmitter and receiver, sent an electric signal wirelessly using Tesla's longitudinal waves 3,000 feet through a small mountain. There was no open line of sight involved in that.
down to the beach and we'll see what we can pick up. Okay, what we're starting with here is we have a copper screen sitting in the salt water.
Okay.
Lead comes up, connects to the neutral lead of the coil.
Right.
And we have a shortwave receiver hooked up to the capacitor directly.
Basically the same setup as a lab bench, but instead of the sink, we're now hooked to the ocean.
Okay, in the laboratory it's about 3,000 feet that way, behind these rocks.
Okay.
All right, that is fascinating imagery, David. And I believe that if those were just regular radio waves, they would not have been able to penetrate through that mountain like that, right? So that leads us to what I believe is the 8,000-pound elephant in the room, figuratively speaking.
Well, yes, I have seen lots of deer and elk around here, but so far I haven't seen any elephants.
That is because the elephant I'm talking about is this part of the Tesla story, right? And it goes something like this, where Nikola Tesla, he develops the AC power system that has been in use all over the planet ever since he developed it. We have him having over 100 US patents. He discovered longitudinal electric waves. He found a way to transmit electricity wirelessly and many, many, many other things. And with all that to his credit, he still went into obscurity in the early 1900s. Why is that?
Bjarne, that's an excellent question. Around 1900, Tesla set up a high voltage lab in Colorado Springs, Colorado. And there he learned to transmit electric energy wirelessly a significant distance, even miles, to the point where people were reporting witnessing sparks flying off their barbed wire fences while he was running his experiments. Later, in the early 1900s, an electric power transmitting station he designed was nearing completion on Long Island, New York. Tesla told J.P. Morgan, who was funding this project, that it was to be more than a radio station, as he had originally told Morgan. He revealed his longitudinal electric wave technology would transmit free electric power to anyone in the world. Morgan said, "I don't do free," and then stopped any further funds going to Tesla. Beyond that, the financial powers that be had Tesla written out of history for decades.
Wow. David, that is interesting, and I see the outline of a familiar story playing out once again.
Once again.
I hope that we can say we've done our part in bringing this little part of the Tesla story out of hiding and into the light. And so as we continue to discover more hidden technologies, David, one video at a time, what do you see coming up in our next video?
We're going into Chapter 4 of Volume 2. It explores tapping zero-point energy. Call it free energy or call it infinite energy, claimed by a number of inventors. You really don't want to miss that one.
That sounds groundbreaking, and thank you, David, for this discourse on transverse and longitudinal electric waves. This is something I now hope would be more readily taught, and maybe, who knows, maybe we'll have wireless electricity up and running in not the too distant future. So I believe that that is all we have for today.
Yes, and thank you for watching, and as always, we appreciate your upvotes and subscribing. And until next time, we say, see you next video.